Hi students, welcome to our YouTube channel. In this class we are going to learn about formation of BeCl2 molecule using hybridization. But in the previous videos we explained what is hybridization, how many types of hybridization, what is sp hybridization, what is sp2 hybridization, what is sp3 hybridization. Now an important question for 8 marks question students according to new question paper pattern, so for AP, and also for 4 marks in Telangana syllabus, most important chemical bonding class 10 PS. So explain the formation of BeCl2 and boron trifluoride BF3 molecule using the concept of hybridization. So now this question actually in the textbook in the form of what is hybridization, explain the formation of BeCl2 molecule and BF3 molecule using the concept of hybridization. Students, most important for 4 marks. In BeCl2 molecule, the central atom is beryllium. So central atom beryllium, because in this beryllium hybridization takes place. So in beryllium sp hybridization takes place as follows. sp hybridization ఏ విధంగా జరుగుతుంది అనేది కూడా మనం ఎక్స్ప్లెయిన్ చేద్దాం. in beryllium atom sp hybridization takes place how like we are going to explain. Beryllium atomic number students 4. Electron configuration of beryllium is 1s2, 2s2, 2px0, 2py0, 2pz0. It is the valency shell for beryllium. So in beryllium atom valence shell is, this is 2, second one is the valence shell, 2s2, 2px0, 2py0, 2pz0. When beryllium participates in the chemical reaction with the 2 chlorine atoms, one electron jumps into 2px. Only one electron. Why this electron jumps into 2px? The energy of the electron in 2s is excited and this is enough for jumping into 2px, but not 2py, but not 2pz. So energy of one electron jumps into 2px. One electron from 2s jumps into 2px0 and jumps into 2px0. So 2s intermixes with 2px to form sp hybridization. So one electron from 2s jumps into 2px. So 2s intermixes with 2px to form sp hybridization with 2 sp hybrid orbitals. sp hybrid orbitals. How like sp hybrid orbitals are formed? So 2s is intermixing with 2px. So you know students, s orbital, it is 2s orbital. It has 2 electrons like that. One electron is jumping into 2px. It is a 2px. So it has no electron. One electron jumps into 2px like this. Then these two combine to form 2 hybrid orbital. It is sp, it is sp. Now it is 1 electron and this is 1 electron. So in beryllium chloride, in the beryllium atom, 2 sp hybrid orbitals are there having 1 electron each. Now beryllium atom is ready to share 2 electrons from sp hybrid orbitals. So these two, 1 electron jumps into this. After combining these two, these are formed. It is its electron, it is its electron. So now chlorine, you know chlorine atomic number is 17. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5 means 3px2, 3py2, 3pz1. So this is the valence shell for chlorine. This is the valence shell. So in the valence shell for chlorine, there are 7 electrons. There are 7 electrons. To get 8 electrons like argon, it requires 1 more electron. It requires 1 more electron. That is why out of 7 electrons, 1 chlorine atom is ready to share only 1 electron from 3pz orbital. But beryllium is ready to share 2 electrons from sp and sp. But beryllium is unable to share 1 electron. Beryllium is ready to share 2 electrons, 1 from each hybrid orbital. But chlorine is ready to share only 1 electron from 3pz orbital. Why chlorine is ready to share only 1 electron? Because already it has 7 electrons in the valence shell. To get 8 electrons, it has a shortage of 1 electron. That is why out of 7, chlorine atom is ready to share 1 electron. But beryllium is ready to share 2 electrons. That is why 2 chlorine atoms, in the formula BeCl2 is there. 2 chlorine atoms can share 2 electrons, 1 from 3pz orbital. So chlorine atom has 7 electrons in its valence shell. It is ready to share. It is ready to share 1 electron from 3pz orbital. But beryllium atom is ready to share 2 electrons, 1 from each sp hybrid orbitals. That is why 2 chlorine atoms come with 3pz orbital sharing 1 electron each. So 2 chlorine atoms, 2 Cl atoms, students, this is 2 chlorine atoms, share 2 electrons, one from each 3pz orbital and overlap with 2 sp hybrid orbitals, sp hybrid orbitals to form 2 sigma bonds as follows. To form 2 sigma bonds as follows. This is students entire answer. Last we want to draw the diagram. So you can see chlorine atomic number is 17. Electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5 means according to Hans rule it is written 3px2, 3py2, 3pz1 in the valence shell. So chlorine atom has a 7 electrons in its valence shell. It is it can share here. It can share 1 electron. So chlorine atom has a 7 electrons in its valence shell. It can share 1 electron. But beryllium atom is ready to share 2 electrons, one from each sp hybrid orbitals. So 2 chlorine atoms share 2 electrons, one from each 3pz orbital and overlap with 2 sp hybrid orbitals to form 2 sigma bonds as follows. So this is the central sp orbitals in beryllium. It is students, it is the 2 sp hybrid orbitals of beryllium atom after hybridization. Now each sp hybrid orbital can overlap with 3pz orbital of 1 chlorine in a end-on end manner by sharing 1 electron. So you know the shape of 3pz orbital. Shape of 3pz orbital or p orbital is a dumbbell. It is 3pz orbital of first chlorine and 1 pair of electron is a shared. 1 pair of electron is a shared. That is 1 electron from sp, 1 electron from 3pz of first chlorine. So these two are combining, these two are overlapping in a end-on end manner or along the internuclear axis. So between them covalent bond is formed called sigma bond. Now 3pz orbital having 1 electron from second chlorine. 2 chlorine atoms written here students, 2 chlorine atoms. So 3pz orbital of second chlorine atom can share 1 electron and overlap in end-on end manner with so this sp hybrid orbital, so forming 1 sigma bond. So now after sharing, valency of each chlorine is satisfied. Chlorine atom, each chlorine atom in BeCl2 has 8 electrons. 8 electrons, that is 2, 4, 6, remaining to 8. For second one 6, remaining to 8. 1 sp1, 2 electrons. That is why valency of chlorine is satisfied. Each chlorine atom in the valence shell 8 electrons. But beryllium now has only 2 electrons. So this is here 2 electrons, here 2 electrons. So in the valence shell after the bond formation, beryllium has a 4 electrons, but not a 2 electrons, but not a 8 electrons. So beryllium is not getting satisfied valence shell electronic configuration. That is why beryllium chloride molecule is electron deficient molecule. Electron deficient molecule because after the bond formation, valency of chlorine is satisfied, but beryllium is not satisfied. Each chlorine has 8 electrons after the bond formation, but beryllium has no 8 electrons in the valence shell like a neon, has no 2 electrons like a helium, but it has a 4 electrons. That is why its valency is not satisfied. So BeCl2 is electron deficient molecule. Students, once again Explain the formation of BeCl2 molecule using hybridization. First we want to write what is hybridization in this question. So you know hybridization phenomena of intermixing orbitals of valence shell having same almost equal energy by redistributing their electrons to form hybrid orbitals is called hybridization. In BeCl2 molecule, the central atom is beryllium. In beryllium atom, sp hybridization takes place as follows. Beryllium atomic number 4 electron configuration 1s2 2s2, but remaining subshells you can also write as a 2p0 according to Hund's rule 2px0. So one electron from 2s jumps into 2px0, so 2s orbital intermix with 2px to form sp hybridization with 2 sp hybrid orbitals. This is when beryllium atom combines with chlorine in the chemical reaction, this happens. So this is s orbital and this is px and this is, but you can omit these two. No need to write this because energy of electron is enough to enter 2px. Next, chlorine atom we are taking. After hybridization, we want to explain the sharing of electrons between chlorine atom and beryllium atom. So like that, each chlorine in the 3pz has an unpaired electron. That is why two chlorine atoms can share 2 electrons from their 3pz orbitals and share the electrons from sp and forming a bond like this. So you can also write this one as beryllium is the central atom and chlorine one single bond and one single bond. This is, students, and here bond angle between these two bond angle is 180 degrees. So this is, students, in the next video we can explain formation of boron trifluoride molecule. BeCl2 boron trifluoride. Only one means 4 marks important, either BeCl2 or boron trifluoride, but both means 8 marks important, students. In the next video we can explain formation of boron trifluoride molecule, and you can find almost important question in chemical bonding chapter. Playlist is there in our channel, playlist chemical bond 10th class 2023 important topics, students. That's all today's class.